Hello students, in the previous video we have seen about Dalton's law, its mathematical derivation and its application, and now we are going to discuss another important law that is called as Graham's law, and which explains the process diffusion, and so it is called as Graham's law of diffusion. Okay, so before entering the Graham's law, we must know or we must be able to differentiate the differences between diffusion and effusion. So first we are going to learn what is called as diffusion and what is called as effusion. Okay, so first we can see about diffusion. Diffusion na enna. Okay, dear students, there is a diagram given in your book for the better understanding of diffusion. Let me draw here in a simple manner. Imagine a container which is separated by a membrane. It is a container. At the middle it is separated. Okay, and a gas is taken here. In one of the regions the amount of gas will be larger, whereas the other compartment the amount of gas will be very less. Okay, now what is possible means the migration is possible. Migration of gaseous molecules from the region of higher concentration to the region of lower concentration. So this process is called as diffusion. So what is diffusion? Diffusion is the process in which the gas molecules can migrate from the region of higher concentration to the region of lower concentration. This process is called as diffusion. Is there any doubt in diffusion? I think you may not have any doubts in the process diffusion. Okay, now the second process, that is diffusion, that we can discuss now. What is called as diffusion? Okay, here also the same container, the same type of container we can use. In a container, the gases are taken only in one region and the gas molecules are allowed to move through a small hole in the compartment. Okay, and the movement of the gas molecules through the small hole, so now they are escaping, no, so it's called as escaping tendency. Okay, so this process is called as effusion. So what is effusion? The escaping tendency of a gas from a container through a very small hole, and so the process called effusion. I think you may be able to know the difference between what is diffusion and what is effusion. What is diffusion? Diffusion abdina, the migration of gas molecules from the region of higher concentration to lower concentration, whereas effusion is the process in which the gas molecules are escaping from a container through a small hole. Okay, the escaping tendency of a gas from a container through a very small hole, and the process is called as effusion. Okay, so after knowing about diffusion and effusion, we can know the Graham's law of diffusion. Okay, well, in the examination point of view, these definitions will be asked to differentiate the processes diffusion and effusion. That will be asked in the exams. Okay, Mama? Okay. Okay, this is the statement of Graham's law. So Graham's law states that the rate of diffusion, rate in the sense the speed of diffusion or effusion is inversely proportional to the square root of the molar masses. So this is the Graham's law. It says that rate of diffusion or effusion is inversely proportional to the square root of the molar mass. Molar mass we can represent using the symbol m, and the rate we can represent using the symbol r. So that the mathematical form of Graham's law is RA divided by RB, that is equal to square root of MB divided by MA. RA na rate of diffusion of the gas A, it is inversely proportional to the square root of the its molar mass. Adhe mari RB abdina rate of diffusion or effusion of the gas B, it is inversely proportional to its molar mass. So RB is inversely proportional to the square root of MB. Okay, well? Okay. Now RA, this equation becomes RA by RB, that is equal to PA divided by PB into square root of MB divided by MA. Okay, so this is Graham's law. RA by RB, that is equal to PA by PB into square root of MB divided by MA. Okay, so what is Graham's law? Rate of diffusion or effusion is inversely proportional to the square root of molar mass. Okay, Mama? Okay, so with this, the Graham's law completed.